I want to do one more problem with a trig function because I don't think I did one in the previous video. So let's say we wanted to figure out whether this particular sequence converges or diverges. So what we want to do, let's take the limit. So we're going to take the limit as n goes to infinity of n over 3 sine of 3 over n. Well, one way that we can do this, let's change this to put it on the bottom. So we're going to have the limit as n goes to infinity of the sine of 3 over n divided by 3 over n, okay? Which is basically putting it on the bottom but flipping it. Now, if you see this, it kind of looks like this might equal 1, because if you recall from Calc 1, the limit as x goes to 0 of sine x over x was equal to 1. Can we say the same thing about this problem? Because notice that this is going to infinity, and you don't quite have that. So what exactly can we do? Well, what we're going to do a substitution. Let's say x is equal to 3 over n, okay? So that way I have the limit of sine of x over x, okay? Now, in this case, what is x going to? Because x is not going to infinity. Because this guy, n, is going to infinity, where is x going to? Well, x is going to 0, okay? So if I do the substitution, you can see that this thing is actually going to be equal to 1, okay? So this is just going to converge as well, okay? So this thing will actually be the solution to this particular problem. You just have to do a little of a substitution, okay? And recall some things from Calc 1. Okay, so this was one more problem that I really wanted to do. Okay, but in this video, what I really want to focus on is on something called monotonic sequences. So let's write that down. Monotonic sequences. Okay, so basically, this is what a monotonic sequence is. So a sequence, a sub n, is increasing, okay, if a sub n is less than a sub n plus 1 for all n greater than 1, okay? Otherwise, decreasing, okay? All right, so basically what this is saying is that if I have a sub n, and then the next term, a sub n plus 1, exceeds that term, then what this means is that it's increasing. Okay? If I have a sub n, and it's bigger than the next term, that means that the sequence is decreasing. Okay, that's basically what this means. Okay? A sequence is monotonic, okay, if it is either increasing or decreasing. So if it is always increasing or if it is always decreasing, not both, that's what we call a monotonic sequence, okay? All right, so that's basically what a monotonic sequence is, okay? Now there's something else that we call bounded, okay? So something might be bounded. And basically this is what a bounded sequence is. So a sequence, a sub n, is bounded above if there is a number m such that the following occurs. A sub n is less than or equal to m for all n greater than or equal to 1. Okay? So a sequence a sub n is bounded above if there is a number m such that all of the a sub n's are less than or equal to m. So if I were to kind of look at this as a picture, let's say here is m, here is a number m, okay, and here's my sequence. What this means is that if I had my sequence of numbers, and you can see that they're kind of increasing, but all of the values are less than this number, then what we say is that this sequence is bounded above because there's a number, a maximum number that this sequence cannot exceed, which means that a sub n is much smaller than this number, it's right below it. So that's what it means to be bounded above. Okay, now just how you have something bounded above, you also have it bounded below. So it is bounded below okay, if there is a number little m such that little m is less than or equal to a sub n for all values of n greater than or equal to 1. Okay, so what this means is that if I have this function, okay, and I have this number little m, so maybe little m is right here, and you have this particular sequence that I don't know what it might look like, then if it's bounded below, okay, that means that m is much smaller than the sequence, but the sequence cannot go below this number. Then what we call it is bounded below. Okay, that's what that means. Okay. Now, if it is bounded above or below, then a sub n is a bounded sequence. Okay, so a bounded sequence, basically you have something above and something below that it cannot exceed. Okay, now usually when we're talking about bounded, so whether something is bounded or not, it's usually a little bit hard to figure out whether something is bounded. So, but we'll do a couple of examples of how to kind of determine that. But we won't really emphasize a lot of the bounding stuff. But I do want to emphasize the decreasing or de-increasing because that is really important. So, so one more thing to kind of add, every bounded monotonic sequence is convergent. And I think that kind of makes sense. If you have a monotonic that's either always increasing or decreasing, and it's bounded above by a maximum number, you know that it's going to converge to something. Because you can see here, if you had something that was always increasing, well, you can see that this is going to be the number that it's going to converge to. If you see that this number that's always decreasing, you can see that little m might be the number that it always converges to. So you can see that if something is bounded and always increasing or decreasing, it's always going to converge. So here's some examples. So show that the sequence, okay, a sub n equals n over n squared plus 1 is decreasing. Okay. So there's many different ways that you can do this problem. Certainly try not to plug in numbers because that's not good because you don't really know what the behavior of this graph is going to really what's going to happen to it later on. So really what we want to show is that it's decreasing. So what is, so WTS means want to show. Okay, so it's decreasing. So how do we know if something is decreasing? So if we go back above, we know that something is decreasing if a sub n is greater than a sub n plus 1. So that's really what we want to show, that a sub n is greater than a sub n plus 1. Okay, that's what we want to show. Now we know what a sub n is. A sub n is just this guy, n over n squared plus 1. Greater than a sub n plus 1 is basically plugging in n plus 1 wherever I see an n. So I'm going to plug in n plus 1 on top. I'm going to plug in n plus 1 on the bottom, n plus 1 squared, and then I have a plus 1 there. Okay, and what I'm going to do is show that this inequality is true. Okay, that's what I really want to show. Okay, so the first thing that I want to kind of work with is why don't I just try to FOIL everything out, okay, and see what happens. So I'm going to FOIL, I'm going to have n over n squared plus 1 is greater than n plus 1. So this bottom part is going to be n plus 1 times n plus 1 plus 1. So I'm going to have n over n squared plus 1 is greater than n plus 1 over, this whole thing is going to be n squared plus 2n plus 1 plus 1. So I'm going to have n over n squared plus 1 is greater than n plus 1 over n squared plus 2n plus 2. Okay, what I'm going to do, I'm going to multiply this both sides by n squared plus 1. So this guy's going to go away. So I'm left with n is greater than n plus 1. Then you have this n squared plus 1. And then on the bottom, you have this n squared plus 2n plus 2. Okay? Now I'm going to multiply both sides by the denominator. So I'm going to move this guy to the other side. I have n, move that guy, n squared plus 2n plus 2, greater than n plus 1, n squared plus 1. Okay? I'm going to FOIL this out, n cubed plus 2n squared plus 2n, greater than, FOIL all this guy out, n cubed plus n squared plus 1. So I'm going to have n cubed plus 2n squared plus 2n is greater than n cubed plus n squared plus n plus 1. Notice that if I subtract the n cubed, so that's going to go away. So this guy goes away with that guy. If I subtract this n squared over, okay, what I'm going to have is n squared plus 2n greater than n plus 1. If I subtract the n over, I'm going to have n squared plus n is greater than 1. Okay? Now, if you look at this particular inequality, you will see that, well, if all the values of n are greater than 1, so if n is greater than 1, if I were to plug in 1 in here, the number is going to be 1 squared plus 1, which is going to give me 2. Notice that this is always going to be a bigger number, and they're being added. This is always going to be a positive number. This is always true for any number that's greater than 1. So this is always true. Okay? No matter what number I put in here, as long as it's greater than 1, this is always going to give me something that is true. Okay, so because this is true, we showed this, so we say therefore, okay, these little dots just mean therefore, a sub n is decreasing, which is what we wanted to show. Okay, so using this formulation, it's a little bit long, but you're able to do it. So as long as you can show a true statement, that's what you really want to be able to do. Okay.